Hey everyone, welcome to the very first video, and I apologize for not having the finesse of Mr. Waterman. It'll never happen, but maybe someday. Okay, so say we want to know the derivative at a point when we're looking at a graph. There's a definite technique to this. We want to draw a tangent line, and remember that a tangent line is just simply like where you're touching, like you're kind of approaching the graph and you have it. So you have this line that's just touching at the one point that might be in question. But there's a technique to drawing it. The way you want to do it, this is kind of weird, but you actually come from the inside part of the curve. So we want to go from like underneath, in this case, the inside part of the curve. And I'm just going to move up until basically I've kind of squeezed out, like I have like this bit on each side. I'm going to just move up until I've just kind of squeezed that out, and so it's just there, and then I can draw the line. Bam. Okay, so the slope of this line is going to be approximately the same as the slope at this point. So then finding the slope of the line, we know slope, of course, is the change in y over the change in x. Remember that triangle means change. It's a Greek letter delta. So looking at that, we can go, let's see, this is the point. It's helpful to label points. That I would call 4, 3.5. And now we need to find another point, and I'm going to just look at this line until I can find something convenient like that, which is at 12.5. So just finding that slope. And so the derivative or the slope, we use this notation of like f prime of 4. So we're saying, what is the slope at x equals 4, or in this case time? And we know slope is found by doing like y2 minus y1 divided by x2 minus x1. So f prime of 4, the slope at 4, that's what this means when we say f prime of 4. Which really means the slope at 4. In this case, t equals 4. So t, x, same difference. Okay, so 5 minus 3.5, so change in y's, and then divided by 12 minus 4. Here's a really weird thing. The AP people are totally cool with this as a final answer. You could stop here. That said, let's go ahead and keep going. 1.5 divided by 8, and we could leave it as that. We could also change it as a decimal. We could change it to 3/16 if we really felt like it. However you want to leave it. Now here's the weird thing. We can tell what this means by looking at units. So for our meaning, let's look at the units. So our units for y is feet. So that would be 1.5 feet. And the units of x, or t, is seconds. So we have this 1.5 over 8 feet per second. So if we have feet per second, what would that mean? Like, so this would be originally like a distance from something graph, like could be my cat walking back and forth pacing, and this would be the distance from her cat dish because she always wants food. And so the feet per second is going to be our speed or velocity. So our meaning then is that at time of 4, at 4 seconds, the speed is exactly 3/16 or 1.5 over 8 or whatever that is as a decimal. You could crack out a calculator. I forgot to grab mine. I'm okay with that. So the key thing on this is if you are drawing a tangent line, you want to come from under the curve, or like from on the inside of the curve. Like if it's curved with like a really strong arc. This looks really almost linear here, but like coming down, say, looking at this spot, I would come from the top side. So that is finding the derivative. Derivative means rate of change, like the instantaneous rate of change, how fast something's going right at that moment. And I'm going to say that again and again. So derivative is your instantaneous rate of change. And if you have just a graph, you can draw a tangent line and find the slope of the tangent line, and the slope of the tangent line is the slope at that point for the tangent line.